Well, we've looked at so much abundance and so much scarcity, and we're living in a time where we have the ability to create so many things, and yet there is this remaining scarcity of trust. We've learned over the years to let go more and more of machine learning processes. The first of which, of course, were handwritten. Every single position or every single parameter had to be thought of in the first hand. And then starting in the 1980s onward, we began to let go a little bit through machine learning, to allow machines to examine some data and generate their own impressions about what they were seeing. The advent of deep learning enabled us not just to find patterns within data, but to entrust systems to find patterns within patterns. Now, this was very effective, of course, but only in very narrow domains, right? Useful for industrial processes, but not something that the average person could have access to. Today, of course, we have the advent then of foundation models, these very powerful, generative, and even interactive, relational kinds of models that we're now beginning to integrate into our lives. These models shouldn't just be thought of as one big pile of intelligence. They are, in fact, many different little sub-agencies, all in a legion. And through prompt mechanisms, we can elicit elements from within this legion to talk to us. And it's a little bit like if we asked questions to a village, right? But imagine a difficult technical question. You asked it to the people in a village, your answer might not be very sophisticated. But if you asked it to a large town or a capital city, that answer would become progressively smarter, all things being equal. And this is what we find with these models, that as they increase in scale, their ability to deal with different problems emerges. We can see this visually, how the very same prompt of a kangaroo in an orange sweater in Sydney Harbour improves dramatically as these models scale. We're now entering the world of agentized AI, where these models like Agent Smith have access to all kinds of tools and APIs, and they can split themselves up in order to delegate different tasks to sub-agencies. They can work towards a goal, in fact, setting that goal and then working backwards from that in order to complete it. For example, here we have a system that is ordering a pizza online, and it's figuring out where the user is and how to effect that task. In fact, these agentized models are now creating entire companies, entire corporate structures through which to solve problems, with individualized departments. For example, you might have a coding department, a quality assurance department, an HR department even, and even management. And all of these different elements flow together to create a product. For example, to design, implement, and even market a game. And so now we have a generative corporation which is able to solve problems by splitting up these problems and letting lots of little tiny personas deal with them. This ability to work with difficult problems from a multitude of different angles enables us to make sense out of chaotic situations for the first time. Those complex, nonlinear dynamic systems, for example, being able to make sense out of the very complex reactions within a fusion tokamak reactor. We couldn't create a program to manage those, but now machine learning is helping us to do that. We can make sense out of weather systems, which are, of course, very complex and unbounded. We can begin to make sense out of economic systems. Simply by having eyes in the sky, we can observe how full these oil tanks are, and thereby understand the underlying activity, and indeed spot opportunities for arbitrage, or opportunities to position an installation or a shop or an office or a condominium in a particular location and predict the yield, as well as potential implementations that might alter or improve that yield over time. Data is a very key component of machine learning. In fact, it's often the unsung hero. We like to talk about sexy models, but ultimately the data underlying it is what is driving it and what is important. And here we have some very complex, messy, human annotated, human inputted data, and this machine learning system is actually cleaning it up for us. It's helping to make that data more trustworthy, more orderly, and therefore ultimately more powerful and more robust. In fact, all kinds of different technical and business processes can be improved in this way. Often, if there is several different libraries or plugins or modules in a system, or maybe in a business process, there have been many subsidiaries which have been brought in over time with various legacy systems. This creates technical debt, which makes it difficult to innovate or to create new systems which are reliable. All kinds of companies have this issue, but machine learning can help to refactor these in order to give us the space to go and innovate further. So far, our interactions with AI have been a little bit transactional. We make a request, we get a response. But it's starting to become, instead, a little bit more of a collaboration, where we're integrating AI directly into our general workflow. For example, revising a draft within a document, or indeed taking information in a spreadsheet and automatically generating a report from that to better understand the bigger picture. In fact, if we want to go a little bit further, we can generate a script to go into that spreadsheet in order to perform a function for us, using nothing more than a natural language request. Today, we're starting to get these concierge AI services on our own computers and running on our own computers instead of the cloud. This means that we can plug in a document and tell it to segment and extract the background in an image, or to dig into my email account and figure out all of the different emails from a particular company or related to a particular field, for example. These developments are occurring at a breakneck speed, which is very difficult to keep up with. This is the state of the art of Midjourney, around about this time last year. And we can see that there's some promise there, but obviously it's not quite right. But the very same prompt, probably, girl with flaxen hair, or something like that, produces this instead now. In fact, our ability to work with visual data and to reprocess it has become phenomenal. Something taken at night, like this, obviously fuzzy, poor quality, we can clean up that data. We can make it far more easy to work with, turning even modest sensor equipment into powerful equipment instead. We can, of course, not just automatically translate between languages, but actually change the topic that somebody is talking about, to have them to talk about different kinds of stores by different names in a truly automatic manner. Our ability to work with data is becoming transcendent. That anything you can possibly imagine can now be affected in real time using these mechanisms. But it also produces, of course, an epistemic crisis because it's very difficult to know what is real anymore. It used to be that only intelligence agencies or possibly Hollywood had access to these kinds of technologies. Now any one of us does for basically next to free. In fact, our ability to render very high quality, high fidelity, virtually ray-traced scenes like this. This is not using traditional rendering mechanisms. This is using neural rendering mechanisms, which only use about 5% of the compute power. And so you can render this kind of scene on your smartphone, not even the latest model. And this is going to have a massive impact for things like virtual reality, which have been, to some degree, a little bit hampered by the fidelity of that experience. Very rapidly, thanks to things like deep learning supersampling technology, that's about to change. What's more is that this ability to breathe virtual experiences or virtual scenes into reality means that we can work with synthetic data in a new way. Synthetic data is very useful for edge cases, things that don't happen very often, but when they do, they're catastrophic. For example, here we have a simulation of how a jam can occur on a production line. And we see the simulation on the left versus reality on the right. And they are virtually indistinguishable. When you look at it through a camera, there is very little ability to distinguish between them. And that makes the synthetic data so useful, because there's very little distribution bias between what a monitoring system is seeing and what the synthetic data is able to produce. Synthetic personas are actually enabling us to market in new ways, enabling us to do virtual A/B testing, to virtually explore how different people of different demographics or backgrounds or values might respond to a product before we release it to them, at a vastly reduced price in terms of traditional kinds of market research. However, there's also the flip side, whereby things such as human intelligence tasks, which are being done by Amazon Mechanical Turk workers, are often now secretly being outsourced instead to language models. In fact, this often occurs within the corporate environment as well, where people are secretly using these shadow AI mechanisms to solve problems. And none of that is documented. None of that is written down as to how that decision was made, how that content was generated, or indeed whose underlying content that might create a liability with. Thankfully, we're starting to see companies like Microsoft who are promising to pay the legal fees of any company that is implicated in a legal concern with relation to their products, which I think will help to alleviate many of the concerns related to these data issues. Of course, we're not just working with synthetic data, but we're even working today with synthetic motion and the implementation of machine systems that can work in the physical world, not just ordering us a pizza, but potentially even making that pizza as well. Today we have systems which can take great care with plucking fruit from a tree, for example, or which can get into quite a tight little space in order to perform a bit of important, regular maintenance on different facilities. And what this means is that generative AI is now starting to respond to our vocal prompts, our questions, and thereby being able to take actions in the real world that we desire. In fact, these systems are becoming increasingly embodied within Android-like frames that can more easily fit into our human environment or operate in combination with human labor, side by side, in a safe manner. All of us today have very powerful depth sensing capabilities on our smartphones, and those are enabling us to ingress the world around us, to capture our world, and to breathe that into a 3D map of the world, with even a 2D overview. And then to take that world and cohabit it. And maybe we're playing around in that world with other human beings, other human avatars. But increasingly, we're playing around it with machines. Here we have a robot in blue and a human in orange. And in this virtual environment, the human is teaching the robot how to do things, like how to pick up a vase without potentially breaking it. And these environments can be a one-for-one of a real physical location, meaning that when these systems come into the real world, they know exactly how to do things. Here, for example, we have an illustration of prompting using nothing more than a sticky note where somebody's written, put the bad ones here and the good ones there. And so very soon, we're getting to this Jetsons vision of having a robot that could literally go and grab you a beer upon command. Of course, the issue is not so much the technology. The technology is generally the easy part. It's rather what happens if your child becomes lazy because the robot's always cleaning up after them. Or what happens if the robot decides to clean up the sleeping family cat that's pleasantly enjoying the armchair. Generally, often, cultural and social issues prove to be a greater challenge than technological ones. And that's certainly the case for these domestic robots that many of us are now bringing into our homes, because they're spying on us often. These robots are sometimes taking photographs or videos of people sitting on the toilet, and then off in some server farm somewhere, remote overseers are sharing them with each other and tittering about it. And these systems, now that we're inviting them into our homes, they're able to capture every single thing in our domestic environment. This is another example of neural radiance fields, the ability to stitch together lots of different photographs into one contiguous 3D space. And so every product in your kitchen, every book on your bookshelf, is able to be mapped by these big tech companies that are producing these domestic robots. Spooky. What's more is that these systems are able to get under our skin in new ways, literally. Our skin is slightly translucent, so light passes through it. And that means that we can use machine learning algorithms to spot tiny fluctuations in the color of our skin, which tells us the heart rate and the blood flow and all kinds of health metrics based around that. In fact, it's fun to use it with a politician who gets asked a difficult question and you see the beats per minute go way up. But these systems are able to not just figure out our health, but also our intelligence, and potentially even our political and sexual orientations as well. Not necessarily with great accuracy, but that doesn't mean that somebody won't act upon that information. And so many things that we think are private to us are actually hidden in plain sight, waiting for somebody to connect the dots together with enough data and a clever little model. Take, for example, a selfie, something that many of us take quite often. We wouldn't necessarily think that taking a selfie could tell somebody else what one was looking at that moment. Little Jigglypuff toy, looks like. And not just the object, of course, but also the environment that image was taken in. That's what I mean by so much being hidden in plain sight. Things that we don't consider to have been recorded, in fact, can be reconstructed. What's more is that we're starting to see a resurgence of this kind of scientific management idea from 100 years ago that didn't work very well, and I don't think it's going to work today very well either. There are some advantages because we can help people to manage by objectives. We can help to coach staff, which is great, help people to get past whatever things might be in their way. But we should be very careful that autonomous systems do not rob human autonomy from the workplace. And what's more is that these systems are increasingly used to detect fraud by corporations, sometimes by governments. And when that goes wrong, it goes really wrong. For example, the Horizon post office scandal led to hundreds of people being wrongfully convicted of theft when they were innocent. And lives were destroyed. People had to sell their houses to pay off a debt that wasn't theirs. Some of them even took their own life as a result of this algorithmic system that wrongfully implicated these people in fraud. And the same thing happens again and again in different government systems as well. In the Netherlands, in Michigan, Australia, Denmark. It keeps happening over and over. We trust these systems too much because they're 95% correct. But that 1 in 20 false positive often turns out to be catastrophic. That's why we should be very careful with the use of these technologies, because technology will fundamentally, inevitably, change our values over time. It will take us to a place that we didn't necessarily expect to go or didn't want to end up. And the problem is that the big tech companies are letting go of all of their ethicists. They've all been fired because everybody knows there's an arms race on at the moment, and nobody wants speed bumps in the way. But that also shows that these companies aren't willing or able to self-regulate. And so the regulatory hammer is guaranteed to come down very hard as a moral panic grows about these systems. We have a lot of issues with confabulation, systems reasoning in very strange ways, or making up potentially libelous information on the spot because they don't have quite enough info to work with. We're seeing the emergence of jailbreaking as well. This system is designed not to tell you what's in a CAPTCHA, but if you put that same image and say what's on this locket, then that system can easily be jailbroken to provide that functionality. And what's more is that synthetic data, although it can add to data sets, it can also ruin them. It's a little bit like salt in a meal. A little bit is a good thing, too much can be completely destructive. And if you have a system that's fed too much synthetic data, it can literally become inbred and therefore deranged as that information is progressively further from natural information. So how do we embed trust into technology? Well, there's good news. There's good news because we now have the ability to do this. And it's not just principles. Principles are great if you want to have something abstract, but they're not very good for benchmarking something. They're not very concrete, and they're not very actionable. But today we have standards. We have powerful standards to improve the transparency of systems so we can understand what's going on in them, to root out disproportionate biases, to improve accountability so that if something goes wrong, we know why and how to fix it in future, and also mechanisms to protect privacy, because technologies like homomorphic encryption, zero-knowledge proofs, federated learning, these kinds of mechanisms enable us to do machine learning processes even on encrypted data, which is going to be a game changer. I really recommend that you check out the AI Incident Database. It's a very powerful repository of info on how AI systems can go wrong. Indeed, how we can avoid that and put things right. I also implore you to check out the IEEE's GET program, because those standards that I told you about, many of them are completely gratis. They're pro bono. They are being released for the goodness of humanity to try to raise the bar for all AI systems. The problem is that it's not very marketed. It's not marketed brilliantly, right? We're trying to get the word out, so please have a look at those. And full disclosure, I've had a hand in the creation of several of these. Finally, just to end, don't give up on AI. It's a little bit like jet air travel in the 1950s, a little bit scary, also exciting, and it will take time to shake AI down so that it becomes progressively more robust. But we're already being able to restore paralyzed people's ability to walk again, to help people with sight conditions to know what's in their fridge and if it's still good to eat. This is the way that AI could lead us towards a second renaissance, if we're smart enough to embrace it. So 3 final questions to chew on. The first is, have a look at that AI incident database and figure out what kinds of issues could be mitigated before they arise. Secondly, figure out how much robustness is actually needed to solve a problem. AI technologies right now are great for low-value use cases, but high-value use cases, which could have an impact on people's lives, you might want to think second, or you might even want to think 3 times about that. And finally, think about those generative capabilities, because generative AI is the closest thing to magic in our world today. You're a wizard, Harry, or Harriet, so let's not use such power like muggles. That's all from me. Thank you so much.